Hello, we are in chapter 8. We're on lesson 5. And our topic is determining, do we have a linear graph, which is a straight line? Do we have an exponential, which kind of looks like upward curve? Or do we have a quadratic, which is a parabola? So we're going to discuss the differences. And if I look at a table of values, which graph is it? So here's what we've got. An exponential function means y equals like 2 to the x, or something raised to the x power. It looks like this. And my y values, it's all about the y values, because you know it's all about the y values, right? The y values are multiplied by the same number. That number could be like 1/2. I could be cutting a number in half. I could be dividing by 4, multiplying by 1/4. Okay. My linear function is y equals like just x to the first power. I'm going to add or subtract y values. Or add or subtract the same number. The same number to my y values. Mr. Taylor, can you please give everybody one of these? Ooh. It's like gold. All right. Quadratic function looks like this. Y equals x squared. It's a parabola. There's going to be no pattern in our examples today. So then I have to subtract the y values to find a pattern. All right. The big idea, look and compare the y values. Okay. So I don't have a picture of it, but please realize that I am going to draw a little sketch of these ordered pairs just to make sure that like it looks like something. So -1, 1, 3, 5, 7. How are these y values? I could care less about the x values. You know what? Don't even look at them. The y values. How is that changing? What's happening here? Y values. What's happening? I'm adding by 2. I am. So, what is that? Exponential, linear, quadratic. If I'm adding by the same amount, plus 2, plus 2, plus 2, plus 2. What's that? Which one is it?
Linear.
Linear. Add or subtract the same number to the y values. So, I'm adding the same number. linear, and just to verify, because I want to make sure, no guessing in math. That's not how math works. You just don't guess things. So, plot the points. Check it out. -2, -1. 2 to the left, down 1. -1, 1. 0, 3. It's my y-intercept. 1, 5. Connect the dots, la la la, straight line. My guess of linear was correct. So I did good. It's a linear. I only look at the y values. That's all we're doing today. Look at the y values. How is it changing? It either has a pattern or it doesn't. Can I move on? Okay. All we're doing today is looking at table of values and figuring out how the y's are changing. That's it. How can you determine whether the data in the table can be modeled by a quadratic? This is a quadratic. It tells us it's a quadratic. Quadratic says there's no pattern. So I should subtract the y values to find a pattern. So that's what I'm going to do. Look at the y's. 3, 9, 19. What's that? That's nothing. 33, 51. That's nothing. So there is no pattern. Since there's no pattern, it's not linear. So, no pattern. I am going to subtract the y values. I kind of do it in reverse order. 9 take away 3. 19 minus 9. So I'm like subtracting the two y values. 33 minus 19. 51 minus 33. Hopefully this has some sort of pattern. What is 9 take away 3? 6. Nice. What is 19 take away 9? What is 33 take away 19? 14. What is 51 take away 33? 50. 51. Yes, 18. Okay. Is there a pattern? Is there a pattern? What am I doing? What? Can you tell me? What am I doing? Oh, what's the pattern? There is a pattern. Look at it. What's happening? I see what's happening here. I'm adding 4. I don't know. Okay. There's the pattern. That means quadratic, but I had to, it wasn't obvious to begin with. I had to first subtract my y values and then find a pattern. So this is a quadratic. And you know what's really interesting? Because I'm going to graph it. You know I am. I'm going to graph this, and obviously I can't go up to 9 or 19. So I'm going to count by twos. 2, 4, 6, 8. 2, 4, 6, 8. -2, -4. Anyways, if I count by twos, I'm going to be able to graph part of this parabola because a quadratic is a parabola. All right. 0, 3. Over 1, up 9. Be careful because some of my dots are going to be in the middle of a box. 219. That's kind of crazy. It's like way up here. Anyways, this is like half of my parabola. It's only half of it because I don't know any negative values. -1, -2, -3. I don't know those because my table of values doesn't have it. That's a quadratic. Quadratic takes the most work. Okay. How can you determine whether the data in the table can be modeled as exponential? They already tell me it's exponential. What's exponential? Oh, the y values are multiplied by the same number. Okay, y values are the only thing I care about. It's only the y values. That's just the way that this lesson is. Okay, how does 1 become 2? How does 2, is there a pattern here? What am I doing? Doubling, multiplying by 2. I'm going to put a dot. I'm not going to put an X. If this were decreasing, it would be exponential decay. And I could be like, I'm multiplying by a half. I'm multiplying by a fourth. That would be decay. So yes, this is exponential. I am multiplying by a common ratio. Times 2, times 2, times 2, times 2. If I want to make sure, I could graph some of these. 0, 1, 1, 2, 2, 4. And you're like, that could be a parabola. How do I know? Well, honestly, guys, I don't have any negative values, so I don't know. But I looked at the pattern of the y's, and it would end up going like this. Exponential. Okay. Try some. All right. I only care about the y values. How does 2 become 5? How does 5 become 14? How does 14 become 29? What's happening? No pattern. Oh, wait. I saw that. No pattern question mark. Oh. Subtract the y values to find a pattern. Okay. Negative signs. Be careful, people. -5. Oh, subtract. -5 minus -2. Be so careful. Negative 14 minus negative 5. Negative 29 minus negative 14. Be so careful. Watch out, because these become pluses. Integers.
Minus 3.
Very good. Negative 14 plus 5.
Minus 9.
Good. No. And minus 15. Right? It's negative 12? Wait, I thought 29 and 14 was 15. Yeah, that's right.
Yeah.
Is there a pattern? But how does 3 become 9? How does 9 become 15? What's that pattern? Let other people answer. 6. That's a pattern. Oh, it's negative 6. But anyways, it's by 6. By 6. That's the pattern. It's negative 6. It's really negative 6. That creates a pattern. So, quadratic. So please notice these are both quadratic here. Right here, I had the same pattern, but I had to subtract first. Right here, I had a pattern, but I had to subtract first. Quadratic takes the most work. What about the next one? This last one. So, how does 4 become 12? How does 12 become 36? How does 36 become 108?
Times 3.
Times 3, times 3, times 3. Which is the one where I'm multiplying by a common ratio? Exponential. Times 3. Exponential. And exponential means that I'm multiplying by the same amount. Okay? So, we're stopping here. So I'll put day 1, stop. Is that for me because I did such a good job? Take a look at this paper, please. This is your homework, only 6 problems. Do you guys think this is easy?
Yes.
Yay! All right, I'll stop the video.